create, to have a tool or a kind of framework in which we can create games, about educational serious games, that actually I'm calling it low level because I'm focused here that we actually don't need the most realistic graphics for this kind of games. What we need is games that can give the students the content or just to learn a concept, a concise concept, but can be developed in a fast way. So I'm exploring technologies, if I can just use modern technologies like the students have done here. So I am exploring if it will be achievable to do that in order to give these tools for the teachers so they can use these tools and say that in a month they can develop different kind of games for teaching the different learning concepts that they have in their classes. So I just want to show with this diagram what I'm considering to do. First of all, I know I'm just focusing on educational serious games in the saying that just for classes and at school, because serious games can be applied in everything. So I'm just considering here that I have a subject. So every subject has lessons, and from the lessons we have just concepts. So I can just close this like here, like this. So then I will be focusing on how is that I can use a game just for learning a specific concept. So from this, we are starting to, me and John, because we are working, to think that we can use, or we can be able to use finite state machines in order to teach a concept. So here I will then have tools like the FSM generator tool. I will also have the tool game definition file generator tool, and an extra tool like, and from these two have to be fit in the generic educational SG tool. That will be like the generic framework that will help us to build these similar games for specific learning concepts of each subject. So then this will be generic in the way for each subject, because according to every subject we will have to have different kind of game assets that we can use for building these games. And I'm also considering to use royalty-free game assets, because we know that the assets for games are expensive, and we need artistic skills, we need too many modeling if you want to be specific. And well, the databases that are important for this will be like the FSM database and the teacher game definition file data that the teacher will provide according to the learning concept that he will want to get. So then from this, an important issue as well in the research area is the assessment model that will be built into the numerical education series games too. So we also are considering we can have that one, or we can still be able to use workbooks, student workbooks, so that the teacher can still assess the students, but actually you don't have to have the assessment model between you or in the game. Then, from this, I just want to focus in one thing, in the FSM generator tool for now, so to explain more how is we're planning to build this. This tool, what we call the FSM generator tool, is needed to aid the teachers to create an FSM from a learning concept in procedural form. From procedural form, I'm meaning that a concept can be autofactual or procedural. Procedural means that we will have steps, so you have certain kind of steps, and then you will learn the concept according to those steps that you are going to. The tool will interact with the teacher via the following steps. The FSM generator tool will ask the teacher for the name of the learning concept. Then, ask the teacher to type in the sequence of action and the corresponding appearance of the system after taking those actions. Then, so the program will write the step 1, and then the teacher types in the first action required. Following this, the teacher can type in any changes that the user may see in the system after taking such an action. Then again, these steps will be repeated until we finish the steps that we will have to go to apply this procedural learning concept. Then the program will write step 2 and the teacher action. Following this, the teacher can type in any changes that the user might see in the system after taking this action, and so on. So when the teacher types return well, we will finish the user action, the sequence will be complete. The teacher can select a contiguous subsequence of steps that the computer will mark as ones that can be done in any order. So in this case, the teacher highlights the subsequences and then press the any other button, because maybe some steps in order to do this, to achieve this procedural concept could be done in, and it doesn't matter the order it will be done. So then the teacher will start to write which steps he would need to do for the students to learn this concept, but maybe some of those steps can be done in different order. So then it doesn't matter. The teacher has to be able to say that from those steps, it really doesn't matter the order in which will be done. But many such subconcepts can be classified, but no pair of them may overlap. The teacher concept is then submitted to the FSM generator tool program by the teacher while pressing the submit button. The tool can create an FSM definition file that the FSM manager's class then will read in and perform. So then that's one of the parts of the research that I'm doing on, and then I'm working on it right now and see how feasible it would be to have this kind of tool and then prove it with actually in a real area and in a real environment with teachers and see if it could be worked on or not. Another thing that I'm working on and I want to show it here is that how is that we can extend educational serious games with using an FPS game architecture. So then here, if I consider this FSM manager class that we are working on, and then just interacted with actually the real game, any FPC game architecture, then just we will start to parallelize concepts. I mean, we will have different kind of, how can I say this? In the FPC games, you know that you just have actors like monsters, guns, and this. You are like the player, you're circling these monsters and rooms. So how we can then parallelize this with learning a concept. So then we will just use the same FPS game architecture, but actually we will be trying to give a concept using these FPS games. This will be working together with VSEC. I think I will have talking to them. So we will start to create games for learning, teaching basic concepts like solubility, in which you shoot a gun, but when you are shooting, actually you are shooting elements or grams of, for example, NaCl. So you are shooting grams of these elements, and the player that you are killing actually will be a monster, but the student will be thinking that is the solution. So every time that you shoot, you are actually hitting the monster and adding these grams. And if you have another gun that would say that is the hitter gun, so then you start to fire, and then according to this temperature that you will build in the fire in the monster, then you will kill the monster once you do this reaction, and then you can graph the solubility curve of this reaction with using just FPS games. So yeah, well, this is what we then are planning to do and work with, and hopefully we can have some successful research and measure the students and see if they really learn parallelizing concepts, or they then need just realizing the big simulation, because this would be just a funny way to teach, because actually you are